Welcome to the final video in this section. Today we're going to learn all about outliers. Now, every once in a while when you're looking at a set of data, you might notice that some number is way out in left field or maybe way out in right field. A number that is really surprisingly small or a number that is incredibly large. Sometimes that number, which is also called an outlier because it sort of lies outside the rest of the data, might really skew the data if we are not careful. Let's take a look at an example that we might see an outlier. So here's an application. Let's look at these numbers. The tables show the number of students participating in a talent show over several years. We are supposed to identify the outlier in the data set and determine how the outlier affects the mean, median, and mode of the data. Let's have a look. In 2010, we had 10 students in the talent show. In 2011, we had 13. In 2012, we had 12. In 2013, we had 15. In 2014, we had 28. And in 2015, we had 11. Okay, so let's have a look. Is there an outlier? Well, if we look at the year 2014, there seemed to be a lot of talented people who were involved in the talent show. 28, that seems surprisingly high looking at the rest of the numbers. In fact, it is almost twice as large as the next largest one. So this seems to be the outlier. So there is an outlier in this case, and it is 28. So our next job is to analyze the data set both with the outlier and then without the outlier. So let's have a look. First of all, it might be convenient to order these for us. So if you want to put them in order, we're going to start from the least to the greatest. So we have 10, 11, 12, 13, 15, and 28. Now, let's see if we can calculate the mean for this data set. So, we know we're going to include the outlier 28. So what do we do to find the mean? We have to add up all the numbers together, and then since there are 6 numbers, we have to divide them by 6. When we do that, we notice that we will get 14 and 1300ths with the 3 repeating. So in this case, we're just going to round it off to 14 and 1/10. That will be our mean with the outlier. Next, let's have a look at the median. Remember, the median is the middle number in our data set. Because this data set has an even amount of numbers, we have 2 middle numbers. We have the 12 and the 13. So remember what we need to do? We need to find the mean of these 2 numbers. We add them together, which is 25, and then we divide them by 2 since there are 2 numbers. Remember, dividing by 2 just means chopping the number in half. So if we do that, we know the median will be 12 and 5/10. Now, let's have a look at the mode. Maybe I'll use a different color here. Remember, the mode is the number that appears the most often. In this case, each number only appears once, so there is no mode in this data set. So with the outlier, we see that our mean is approximately 14 and 1/10. Our median is 12 and 5/10, and there is no mode. Now let's suppose we move this to the side and we look at our data set without the outlier. So I'm going to recopy these numbers in numerical order, but I'm going to leave out the 28 because that number seems to not make a whole lot of sense. We'll start with our 10, 11, 12, 13, and 15. Now instead of having 6 numbers in our data set, we only have 5. I'm going to do the same thing. I'm going to calculate the mean, median, and mode, but again, without the outlier, without the number 28. So remember, to find the mean, I have to find the sum of all of these numbers. So I'm going to add 10 plus 11 plus 12 plus 13 plus 15. But instead of dividing it by 6, I only divide it by 5 since there are just 5 numbers in the data set. And when I do that, I calculate that the mean is 12 and 2/10. That's a substantial drop from the mean when I do include the outlier. Next, I want to find the median. Remember, the median is our middle number. Kind of easy to find in this data set since there's an odd amount of numbers. Our middle number is a number exactly in the middle, and since our number is in numerical order, that makes sense. So in this case, our median is 12. Last but not least, our other measure of central tendency is the mode. If we look at all our numbers, they appear only once. So once again, even without the outlier, there is still no mode. Now, let's have a look at our 2 sets of data. One where we use the outlier and one where we didn't use the outlier. So if we look here, we'll notice that the mean is quite high, 14 and 1/10. This seems to have skewed our numbers a little bit because of our big 28. So the mean would probably not be the best measure of central tendency to use. Since there is no mode, that doesn't really help us out either. So in this case, with the outlier, the median is the way to go. So I would use this measure of central tendency at 12 and 5/10. Now, if we look at our data set without our outlier, again, we can eliminate the mode right away since there is no mode. And in this data set, I would probably say that the mean, which is 12 and 2/10, would be the best measurement to use. Although the median is quite close, so both of them would be acceptable. They both seem to capture what's happening right around the middle of our data set. Again, if we use the outlier, not the mean for sure, definitely the median. If we don't use the outlier, I would say that in this case, the mean or the median would both be acceptable, but I'll lean a little bit towards the mean. Otherwise, you truly will lose the sense of what the data is representing if you use the mean in this case. And here, again, it seems to be okay for either of them. You'll notice that sometimes when you do use an outlier, it wrenches up our number crunching a little bit more. So to summarize, a number in the set of data that is significantly different from the other numbers is called an outlier. Here's the outlier. An outlier is much greater than or much less than most of the numbers in the data set. Outliers sometimes occur as a result of error in measurement or recording. In these cases, outliers should be ignored. Sometimes an outlier is an important piece of information that should not be ignored. For example, if one student does much better or much worse than the rest of the class on a test. Outliers might not always be obvious. Identifying outliers is then a matter of choice. Thank you for watching, and please proceed to the Try This section.